So when two events are said to be independent, the probability of occurring one event does not affect the occurrence of other event. Then we say that these two events are independent event. Okay. So these two events, whatever events we are taking, such that the probability of that event is non-zero. Okay. So the two events A and B have non-zero probability of occurrence. That is, probability of A is not equal to 0, probability of B is also not equal to 0. Okay. When you say these two events are statistically independent, if the probability of occurrence of one event does not affect the occurrence of other event, then we say that these two events are statistically independent. Okay. Now, mathematically, how do we denote? The probability of A given B is equal to probability of A. Okay, since these two events are what? These two events are independent. The occurrence of one event does not affect the occurrence of other event. So, probability of A given B. B is already occurred, but it does not affect the occurrence of A. That is why what is its value is probability of A itself. Similarly, probability of B given A is equal to probability of B itself. Okay. So, the independence also means that the probability of joint occurrence of two events must be equal to the product of two event probabilities. When you say that two events are independent, the joint probability, what is joint probability? The probability of A intersection B. The probability of A intersection B is called joint probability. It is equal to what? Probability of A into probability of B. Okay. So in that case also these two events are said to be independent. Okay. Now what is this equation 3? So this equation 3 is the necessary for two events to be independent. Okay. So when you want to check whether two events are independent or not, how do you check it? We have to check this equation. If any two events are satisfying this equation, then we say that those two events are independent events. Okay. Now we also know that if two events are mutually exclusive, so what is mutually exclusive? If two events are mutually exclusive, what is A intersection B will be equal to null set, yes or no? It will be equal to null set. So what is the probability of A intersection B will be equal to
0.
0. So if two events are mutually exclusive, probability of A intersection B is equal to 0. When two events are statistically independent, when two events are statistically independent, what it has to satisfy? The probability of A intersection B should be equal to what? Probability of A into probability of B. Yes or no? So, when two events are mutually exclusive, they cannot be statistically independent, because this is the condition for two events to be statistically independent. This is the condition for the two events to be mutually exclusive. Okay. So if two events are statistically independent, only this condition is satisfied. This will not be satisfied. Okay. If two events are mutually exclusive, this condition will be satisfied. This will not be satisfied. Okay. So when two events are mutually exclusive, they cannot be independent. Okay. If see here, two events cannot be both mutually exclusive and statistically independent. It is not possible, because in order for two events to be independent,